What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exam. So let's get into it. In this video, you're going to learn about various architecture and infrastructure concepts such as cloud computing, infrastructure as code, serverless architecture, and microservices. All right, so let's talk about cloud computing. So cloud computing, this is a way of offering on-demand services that extends the capabilities of a computer or a network. These might be free services such as personal browser-based email from various providers, or they could be offered on a pay-per-use basis such as services that offer data access, data storage, infrastructure, or online gaming. A network connection of some sort is required to make the connection to the cloud and gain access to these services in real time. Now, some of the benefits of using cloud-based services include lower costs, less administration and maintenance, more reliability, increased scalability, and possibly increased performance. A basic example of cloud-based services is browser-based email. A small business with a few employees definitely needs email, but it might not be able to afford an email server and perhaps does not want to have its own hosted domain and deal with the costs and work that go along with that. By connecting to a free web browser-based service, the small business can obtain nearly unlimited email, contacts, and calendar solutions. However, this model offers the business no administrative control, and there are some security concerns. All right, next, let's talk about the responsibility matrix. So a responsibility matrix in cloud computing, this outlines the division of responsibilities between a cloud service provider and a customer. This matrix, often called a shared responsibility model, defines who is responsible for security, compliance, operations, and management in a cloud environment. Unlike in traditional on-premises environments where the organization handles every aspect, in the cloud, responsibilities shift between the cloud service provider and the customer, depending on the service model, such as infrastructure as a service, platform as a service, and software as a service. Under typical circumstances, the CSP is responsible for the underlying infrastructure, including the physical hardware, networking components, and data center facilities. It manages the core cloud computing resources, such as virtual machines, databases, and storage, ensuring their availability, scalability, and security at the infrastructure level. For higher level services, such as platform as a service or software as a service, the CSP might also be responsible for application hosting, runtime environments, and underlying operating systems. So you must carefully read all agreements to understand what the CSP is responsible for in your situation. The customer's responsibility varies based on the cloud service model. So with infrastructure as a service, the customer is typically responsible for operating systems, applications, and data, while the CSP takes care of the underlying infrastructure. With platform as a service, the customer's responsibility shifts to managing the applications and data, and the CSP handles everything else. The customer's responsibility in software as a service mainly involves working data and user access, and the CSP takes care of almost everything else. Now, it is important for a customer to understand their responsibility in maintaining security, compliance, and data integrity as outlined in the service agreement with the CSP. And understanding this division ensures that security controls are implemented correctly and compliance requirements are satisfied. All right, next, let's talk about some hybrid considerations. So a hybrid cloud, this is an architecture that integrates private and public cloud services, facilitating data and application sharing between them. A hybrid cloud provides flexibility, scalability, and diverse deployment options, but demands careful consideration of data integration, network connectivity, security, compliance, and cost. A well-architected hybrid cloud offers the control of a private cloud combined with the efficiency of a public cloud. However, it may present challenges in managing multiple environments and ensuring smooth integration. And the following are some special considerations in hybrid environments. So you have data integration. Hybrid clouds allow seamless data sharing between private and public cloud environments, which can create complexities in data synchronization, consistency, and governance. So proper data integration techniques are essential to ensure seamless data flow and accessibility. The next consideration is network connectivity. A hybrid cloud demands robust network connectivity to enable seamless communication between private and public environments. And challenges include maintaining secure and fast connections, minimizing latency, and implementing consistent networking policies. Another consideration is security. So security considerations in a hybrid cloud can be complex as data and applications may reside in different environments, each with unique security protocols. Unified security policies, encryption, and identity management are essential to safeguard data across all domains. Then we have compliance. So regulatory compliance can be challenging due to differing legal requirements in public and private environments. So careful alignment of privacy policies and compliance controls across the hybrid infrastructure is crucial. And then we have cost. So while a hybrid cloud provides flexibility, managing multiple environments can increase complexity and cost. Effective cost management requires understanding the pricing structure of public cloud services and the overhead of maintaining private infrastructure. Next, let's talk about third-party vendors. So third-party vendors are external organizations or service providers that offer specialized services or applications that integrate with the cloud provider's offerings. Third-party vendors may provide specialized security tools, analytics platforms, or industry-specific applications, enhancing the cloud environment's functionality. Engaging third-party vendors bring added capabilities, but also introduces risks, including potential security vulnerabilities or compliance issues. And a significant risk of leveraging third-party vendors is the increased exposure of the organization to vulnerabilities it might not be able to manage. All right, next, let's talk about infrastructure as code. So modern applications and deployments, whether they're on-premise and in the cloud, they require scalability and integration with numerous systems, APIs, and network components. This complexity introduces risk, including network configuration errors that can cause significant downtime and network security challenges. Consequently, networking functions such as routing, optimization, and security have also changed. The next generation of hardware and software components in enterprise networks must support both the rapid introduction and rapid evolution of new technologies and solutions. Network infrastructure solutions must keep pace with the business environment and support modern capabilities that help drive simplification within the network. And these elements have fueled the creation of what is called software-defined networking. Software-defined networking was originally created to decouple control from the forwarding functions and networking equipment. And this is done to use software to centrally manage and program the hardware and virtual networking appliances to perform forwarding. Organizations, they are adopting a framework often referred to as infrastructure as code, which involves managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. All right, next let's talk about a serverless architecture. So another popular architecture is the serverless architecture. Be aware that serverless does not mean that you do not need a server somewhere. Instead, serverless architecture involves using cloud platforms to host and or to develop code. So for example, you might have a serverless app that is distributed in a cloud provider like Amazon AWS, Microsoft Azure, or Google Cloud Platform. And serverless, this is a cloud computing execution model in which the cloud providers such as AWS, Azure, Google Cloud, and so on, they dynamically manage the allocation and provisioning of servers. Serverless applications, they run in stateless containers that are ephemeral and event triggered, which means they're fully managed by the cloud provider. And AWS Lambda, this is one of the most popular serverless architectures in the industry. In AWS Lambda, you run code without provisioning or managing servers, and you pay only for the compute time that you consume. When you upload your code, Lambda takes care of everything required to run and scale your application, offering high availability and redundancy. All right, next let's talk about microservices. So the term microservices, this describes how an application can be deployed as a collection of services that are highly maintainable and testable and independently deployable. Microservices are organized around business capabilities and enable the rapid, frequent, and reliable delivery of large, complex applications. And most microservices developed and deployed by organizations are based on containers. Application programming interfaces or APIs, such as RESTful APIs. They are the frameworks through which developers can interact with an application. Microservices use APIs to communicate with each other, and APIs can also be used to expose data and application functionality to third-party systems. Microservices and APIs, they need to be secured, and traditional segmentation strategies do not work well in these virtual and containerized environments. The ability to enforce network segmentation in container and virtual machine environments is called microsegmentation. Microsegmentation occurs at the VM level or between containers in either a VLAN or a subnet, and microsegmentation solutions need to be application aware, which means the segmentation process starts and ends with the application itself. And then most microsegmentation environments apply a zero trust model, which dictates that users cannot talk to applications and applications cannot talk to other applications unless a defined set of policies permits them to do so. All right, so that was my video where you learned about various architecture and infrastructure concepts such as cloud computing, infrastructure as a code, serverless architecture, and microservices.